Okay, welcome back. Good morning and happy Monday. I hope we had a great weekend. So a couple of little things before we jump into the math today. First of all, and I mentioned this a couple of minutes ago, if you haven't started looking at any of the projects, I would encourage you to start looking at them sooner rather than later, just so you can get a realistic sense of what the expectations are on your time. The next thing I want to talk about is the homework. So as we pass the homework back and forth in these folders, you're going to be looking for some funny numbers at the top of the graded homework. 4, 2, and 2 is what you hope for because that is a perfect score. So let me just make clear what these numbers represent. The first number is the homework grade. It's out of 4 points possible. So if you do half of the homework, you'll get 2 points out of those 4. I'm not checking answers. In fact, I'm hardly checking anything at all. I'm just looking to see a legitimate attempt on all the homework. You can check answers in the back of the book and with each other and with me. I think there's an answer key across the hall, but this is an attempt grade, not a did you get the answer correct grade. Questions of the day, those are also assigned every day, and 2 points is the maximum score here. And then finally, if you show up and participate, which everybody is doing wonderfully, 2 points again is the maximum score there. Okay, so 422 is what you're hoping for. Brendan. Yep. Oh, yeah, so I can grade any piece that you happen to have whenever you have it. Yeah, good. Other questions on the attendance is pretty much a one shot only. Yeah. Okay, so that is that. Something else. Oh yeah, more resources, just so you're clear on what you have available. Let's go back here. So this is our Moodle page. I don't know if you've logged in yet, but you might give it a look if you have a moment. So here's our Moodle page. Let's see, class announcements. You never need to look there for my purposes. If I have an announcement to make, I'll email you. The syllabus is there. A nicer version of the calendar is there, like this Excel file is there, as opposed to the slightly blurry version of that calendar you have on the syllabus. There is a homework forum where you can explore and ask homework questions of each other. I have never been in there. I don't know how much activity there will be, but it's there in case it's something that you guys are interested in. What I wanted to point to are 2 things. First of all, down here in the class videos section, there's a link to Caitlin's playlist and a link to my playlist. So if you click on it, it brings up the YouTube playlist. Today is class number 3, so it will get populated throughout the semester. And then the other thing I want to show you is in the class notes section of our Moodle page. If you click on packet 1, the first document is a clean PDF of the packet that we are filling in together. The next one is, it has my name in it, and then the next one has Caitlin's initials in it. And so if you click on the one with my name in it, then it will open up a PDF that looks like this. And so I wanted to just make clear to you that you have access to the entire set of stuff that I write up here on the smartboard in color. So if I'm writing things down and it's too quick for you to copy, stop copying it. You can just check it out on Moodle. I'd rather have you here thinking than here scribing. Okay, so always you'll have that available, whatever I write on the smartboard. I can't promise I'll do this every day. I'll do it at least once a week after Friday's class and maybe more often if I'm able to. Okay, any questions on the resources? Okay, so let's jump in with our calendar here. So this is class number 3. Today we talk about limits and continuity in section 1.8. Again, our first quiz is coming up on September 19. Projects are due September 24 and 26. Questions on the timeline? Okay, then here on page 17, we'll jump up to the top. Actually, whoever's reading will need to read off of my thing because I made a slight correction here. So can we go to Andy? Can you read the daily summary?
Daily summary. In this class, we will calculate limits and discuss continuity. Limits are at the heart of finding slopes of a tangent lines, which is a fundamental process. Calculus I.
Thank you, Andy. Okay, so we're going to see one example of a limit, and then the group activity is like massively long today, so you're going to spend a bunch of time talking about limits with your neighbors. So here's the first thing we're going to try is this limit right here. It's the limit as x approaches 0 of that stuff, x over square root of x plus 1 minus 1. Okay, so here's a key. First thing to try when you see a new limit is to just plug in. Just plug in x equals 0, and let's see what happens. So what do you get on top when x is 0? Well, it's plain old 0. On the bottom, there's a little bit of work to do, so I'll write it out. That x becomes 0, and then I'm copying everything else. Everyone see what we did there? Just plug in, all the x's are 0. How much do we get on the bottom? This is not a calculator question. That is 0, yes? Right. That's the square root of 1, which is 1 minus 1. So we get 0 divided by 0, which is weird. I mean, it's undefined because there's a 0 in the bottom. And if I just said, 7 over 0, then I'd expect you to tell me, okay, that's undefined. But this is 0 divided by 0. And what's strange about it is that if I just tell you, hey, I've got this fraction and it's 0 over, who cares? What is the fraction equal to? It's 0, right? 0 out of 7, 0 out of negative 28, they're all 0. So it's like these two things that both have their own separate rules, but then we put them together and kind of shrug our shoulders. So if you get 0 over 0, what that means is that there's some more work for you to do. That's what it means. So here's the work. We're going to take a look at screenshots of the graph. So here I've typed out here y1 is the thing we're trying to find the limit of. And then just so you can see the window there, minus 5 to 5, and then 0 to 5 on the y. And then I'm taking a look at the graph of that function. Okay, so we are sending numbers very close to 0. So as x gets closer and closer to 0, the question is, what happens to the y values? So as we go this way, it sure looks like we're approaching whatever that magic number happens to be there. And do you see the same thing happens when you approach 0 from the left-hand side? We just approach that same, whatever that number is. Can you guess what that number is looking at the graph? Looks like 2, right? We count the hash marks and read the window. So it sure feels like the answer is 2. So that's going to be our first guess. I mean, I can't tell if it's 2.1 or 1.8, but if it's a nice number, it sure feels like it's going to be 2. And then maybe more compelling evidence is here in part B, where we look at some screenshots. So again, the same function. I think a bunch of groups were able to do this business inside of the table setup where you change the independent variable to ask, because that allows you to plug in any numbers you want instead of just numbers in an ordered sequence. And so take a look at the numbers that I've plugged in here. What can you say about these numbers? 0.1, 0.01, 0.001, what are we approaching? 0. So I chose those numbers so that we could get really close to 0. And then the same thing here, but from the left-hand side. So like, this is the same green arrow that we drew before from the left-hand side, and then the purple arrow is coming from the bigger than 0 side. What happens if you actually just plug 0 in? You get an error. It's 0 divided by 0. So it's not just a waste of time to try to head towards 0, because you can't just plug 0 in. Like, it's the only thing we have is to get near 0, but not quite there. Okay, so looking at these purple numbers here and these green numbers here, what do you make as your guess for what we're approaching? Sure feels like we're approaching 2. So more compelling evidence to suggest the limit is 2. Okay, but I know that you guys are very discerning mathematically, and having a picture and making your best guess from a table is okay, but it's not like super concrete proof, right? And so to really show legitimately that this limit is 2, we got to do a little bit of algebra. So here's the algebra that we do. I'm going to copy that limit from the very beginning. Somebody double check, that's what it was? Okay, so it looked like things were approaching 0 divided by 0, and we have to do something to rectify that. So here's what we do. I'm going to multiply top and bottom by some magical thing that I'm guessing you've seen before. It's this thing here. Yeah, definitely got to multiply by the same thing. So the value of that red fraction is 1 because it's the same top and bottom. What's the name of the thing that I put in top and bottom? Starts with a C. You see what we did? I just copied this thing, but I changed the sign in the middle. You guys remember seeing that in some previous math class? It's called the conjugate. And the effect it's going to have is going to be to clear that radical from the bottom. The radical will completely disappear from the bottom once we do some algebra. Sometimes it's called rationalizing the denominator. All right, so now we've got our algebra to do. Upstairs, there's nothing that's going on. I'm just going to copy it again, but bring them both to the same fraction. So multiply straight across the top by copying it down. But the bottom is where the fireworks happen. So I'll throw some parentheses around here so we really understand we are doing this double distributing or FOIL. So when we do first times first, root x plus 1 times root x plus 1, what do we get? Just x plus 1. And then when we do the outers, combined with the inners, what happens? Outers and inners cancel. Do we see that? Outers is a positive root x plus 1. Inners is the negative of the same thing. Okay, so they cancel. That's great. So all that's left over is the last. Negative 1 times positive 1 is negative 1. Any questions on the foiling? Okay, now life is about to be good because what happens on the bottom? We just get x, which is lovely because we can do what now? We can cancel, right? That x right there is ready to go with that x right there. And we're no longer dividing. And this thing that's left over is essentially a brand new limit. And I mentioned it up above, but every time you see a brand new limit, the first most elementary thing to try is to just plug in. So we are just going to plug that 0 in to this thing in the parentheses, and we'll have our answer. Square root of 0 plus 1, and then plus the 1. See it? Anytime you have a new limit, first thing to try before anything else is to just plug in. So that's the square root of 1 plus 1, which is 2. All right, now we firmly believe the answer is 2. The graph led us to that answer. The table led us to that answer. This is a proof that that's the answer. Brendan. It's the same graph, but you know, from the graph we couldn't tell if it was really 1.997 versus 2. It's legitimately 2. Okay, last thing, and then it's group activity time. What happens if you try plugging x equals 0 in here? What do you get down there on the bottom? You get 0, which is still a problem. What happens if you try plugging x in here? 0. So what made it work magically was that you finally lost that x in the bottom. That's the first time where plugging in gave you something other than 0 over 0. Questions on this? Okay, so the activity, like I said, is really crazy long. And so a couple of things. First of all, you're going to need to move if you're going to get through all this entire activity. We have 55-ish minutes, 56 minutes, and you're really going to have to use those minutes effectively to get through the entire thing. Over here on the whiteboard, I'm asking you to skip problems 2, 5, and 6 in the activity, 2, 5, and 6. I'm hoping that at the end you will have time to come back and do number 2. You can really skip 5 and 6 altogether. I think 2 is a great question, but I want to move that to the end, okay? So go ahead and start with number 1, and do not dawdle.